This video covers our MATLAB API for communicating with BlackRock's Stim R96. If you haven't done so yet, you may want to watch through our Stim Manager software video. Understanding how the GUI works will help you better understand what the MATLAB API calls correspond to. Additionally, before we get started, you will want to be sure that you have downloaded Stimmex if you haven't yet. It comes with a number of examples that we will talk through in this video. With that, let's go ahead and jump into it. Stimmex is our method for communicating with the Stim 96 through MATLAB. This can enable us to create complex stimulation parameters that are either beyond some of the capabilities of the GUI, such as randomized trains, or it may just allow us to integrate into our experimental control setup in a way that we prefer. Whatever the reason, this video will cover the basics of working with Stimmex, including connecting to the stimulator, getting information from the stimulator, and the creation of stim patterns and basic programs. To ensure that Stimmex has something to communicate with, make sure that the Stim Manager software is installed and that the Stim is plugged in and powered on. After meeting those conditions, we can go ahead and open MATLAB and begin walking through our first example. After opening MATLAB, let's make sure we have navigated to our folder containing Stimmex and the examples. Let's go ahead and open up our first example, Stimmex Simple Program. Let's just walk through this line by line so that we can see what the most basic Stimmex functions are. After that, we will look at some of the other capabilities within Stimmex, including a quick tour of the documentation. The first few lines are just to clear everything else so that we can keep our explanation and workspace very clean here. The real stuff starts when we connect to the simulator with the following lines. The first line creates the simulator object, and the second line calls the connect method, which will connect the instance to the currently plugged in stimulator. The most basic function of the stimulator is to provide stimulation pulses to the electrodes. But before it can do that, we need to define what those patterns should be, and we do that with a setStim pattern. This method has its parameter broken up over multiple lines to make it easier to see and interpret and allow us to put better comments in here. We can think back to the stim pattern creator that we saw in the GUI and realize that we are defining the exact same parameters here for nearly everything. The one exception is this first parameter, the waveform parameter. This waveform ID is used when referencing which waveform that we want to stimulate with. We will see how that works in just a bit. Polarity uses a binary choice to select cathodic or anodic first, but otherwise each of the other parameters should be fairly self-explanatory after using the GUI. If you ever write a script and get an error on the line that contains setStim pattern, it is almost certainly because of one of two reasons. Either one parameter is out of spec of the stimulator, or you've exceeded the memory limit. What do I mean by that? While the stimulator is capable of hitting certain frequencies and pulse times, it does so by setting memory on each current module in that device. Sometimes, very low frequencies combined with short widths can lead to wait times that the stimulator must create that exceed the memory capability of these modules. We mention this here because this error is not as easy to spot when working with the MATLAB API as opposed to the GUI. For more information on this, you can read into the manual or contact support at blackrockmicro.com. After defining our waveform, we have a few other options. We can manually stimulate with that waveform using the manual stim method, or we can incorporate this waveform into a program and execute that whole program. Since we want to talk about a program creation as well, let's explore that path instead, and we can discuss manual stim a bit later. The next section of this creates a program, using the begin and end sequence methods. These provide starting and stopping points for the program definition, and any program instructions should be included here. This is a very simple program, so all we do is begin the program, stimulate on channel 1 with waveform 1, and then we stimulate on electrode 2 with waveform 1. This waveform ID here is the same one that we defined above when we defined our waveform. You can see that you could reference multiple waveforms here to perform more complex programs. But of course, each of those waveforms would need to be defined. You can also create groups of electrodes to stimulate at the same time using the begin and end group commands. After typing end sequence, our program is defined. But, just like the GUI, it doesn't yet execute because it is defined. We need to actually tell the program to execute. Like the GUI, you could have this execute on trigger mode, but here we will just tell the program to execute manually twice. Creating custom stimulation parameters with Stimmex is as easy as these 4 steps: connect, define, program, and play. Nearly every stimulation program boils down to this process, but it is how you control the movement through this process that creates great experimental control. To give you an idea of how you can take this program further, let's take a quick look at how we can look at Stimmex documentation. To access the built-in Stimmex documentation, simply type help Stimmex and then click on Serostim 96. Stimmex will provide a list of methods available and a summary of what they do. You can look on an individual method and it will give you more information on it. Clicking on manual stim, for example, can tell us that the required parameters and the available ranges for each. If you look at the other commands, you can see the begin and end group commands discussed earlier, but you'll also notice a number of commands centered around getting information from the Serostim, such as getting the current voltage limits, active modules, etc. That concludes our quick tutorial on the basics of Stimmex. We covered everything required to get started in executing custom programs with our MATLAB API, including defining waveforms, defining programs, and performing manual simulations. For additional questions on the stimulator GUI, latencies, or other specifics, you can check out our Serostim video, Stim Manager video, or find manuals on the website at www.blackrockmicro.com.